Let's look at this. As you can see in this place, we are asked to find the y ds of this function, that is this equation. We are going to apply chain rule, function of a function. What is that? If you don't want to use chain rule, what you will do here, you will simply come here to say y is equals to this plus this in two places. Then you expand. This time this is s squared plus this time this is s, this is x, this is 1, right? That is s squared, this is 2x plus 1. Then you say the y over the x equals to, this is 2x plus 2. That is the answer. You are good, right? No problem. Now, help me solve this. If I give you y equals to s plus 1 raised to power 100. How are you going to do it? You have to expand it like this in 100 places. You are joking. You are joking. You are simply joking. That is when chain rules comes in. Chain rule is saying, if you have anything like this, it's like compound. Compounded together. Don't worry yourself. Y is equals to s plus 1 raised to power 2. It says, replace this one with something else. It could be u, it could be v, it could be a, it could be anything. Okay? It could be anything. So what we're going to do now, I'm going to say z is equal to s plus 1. It means therefore, say let z be equals to this. It means therefore, y is equals to z raised to power 2. So now, remember what we are looking for is not the y dz, we are looking for the y dx. The rule says y over the x is equals to the y over the z multiplied by the z over the x. This and this will cancel. You are still going to have the y over the x. Let me explain. As you can see in this place, we are looking for this. We want z to assist us because we don't want to go into complexity. Okay? So therefore, we simply use chain rule. The y over the z multiplied by the z over the s. Let's see. Now that we have this, let's first of all find the y dz. That is, the y over the z equals to, that is here, 2z raised to power 2. Remember, you move 2 here, you reduce this 2 by 1. Okay? It means therefore this equals to 2z raised to power 1, which is 2z. We have one leg of it. Then the z over the x. What is that? The z over the x. That is here. The z over the x. Here, the y over the z. We have done that. The z over the x. That is to say, we come here now. Remember, z is equals to s plus 1. So therefore, it's equals to, what is here? It's 1, right? We bring 1 down. We reduce 1 by 1. This is already 0. Differentiation of what? A constant. If you don't understand that, go to our previous videos. You see that. That is 1x raised to power 0. Anything raised to power 0 is 1. So the answer is 1. So finally, we now have the y dz as 2z. We have the z over the s, which is 1. We need to substitute now. That is to say, for this, the y over the x is equal to the y over the z, which is this, 2z multiplied by the z over the s, which is 1. What is the meaning of z? Z, as you can see in this place, is s plus 1. That is to say, 2s plus 1 multiplied by 1. Finally, you agree with me, you have 2. That one means nothing. Expand 2s plus 2. Or you leave it like this or like this. Any one you want to do.